Good evening to all. My name is K. Bhuneshwari. By my roll number is 461. Today my topic is introduction and classifications of signals and systems. Introduction to signals and systems. Signals are functions that convey information about the behavior of system over time or space. Systems are devices or processors that analyze, modify, or generate signals. Understanding signals and systems is a fundamental in engineering fields such as communication, control, and signal processing. Signal. What is meant by a signal? A signal is a time varying or space varying quantity that carries information. Signals can be classified based on their properties, such as continuous or discrete. For example, include audio signal, images, and sensor data. Types of signals: continuous and discrete. Continuous signals are defined for every instant of time, such as analog audio. Discrete signals are defined only at specific time interval, like digital audio samples. And the distinction is important for processing and analyzing methods used in different systems. Classifications of signals: deterministic and random. Deterministic signals can be precisely described by a mathematical function. Random signals involves uncertainty and are described statically. If the example include a sine wave, deterministic signal, and a noise signal is a random. Here the example diagrams. Deterministic signals is a continuous sine wave. Here the random signal is a there is no amplitude on the same negative and positive side if the waves are in random. Time domain and frequency domain. Signals can be analyzed in the time domain or the frequency domain. The time domain analysis focuses on the how signals change over time. Frequency domain analysis reveals the spectral content of signals essential in filtering and modulation. Here we see in the diagrams. What is meant by a system? System. A system is a process that produces an output signal based on an input signal. Here we can give x of t is the input signal if the system produces a output y of t. The system can be classified as a linear or non-linear based on the response. Understanding system behavior helps in designing and controlling engineering processes. Types of systems: continuous and discrete. Continuous system operate and continuous signals are described by a differential equations. Discrete systems works with discrete signals and are using a difference equations. Both type are used in different applications and depending on their signals involved. Time invariant and varying system. Time invariant system has the property that it do not change over time, and the time varying system have the characteristics that change with time. These classifications affect the system analysis and the design of a control strategies. Linear and non-linear system. Linear systems satisfy the principle of superposition and homogeneity. Non-linear systems do not satisfy the principle of superposition theorem and are often more complex. More real-world system exhibits some degree of non-linearity influencing their analysis. U of t, we can give input. The system produces y of t1. Causal and non-causal system. Causal system depends only on past and present inputs. Non-causal system requires future inputs to determine the output. The causality is a key concept in the real-time signal processing application. Stable and unstable system. Stable system produces a bounded outputs for bounded inputs. Unstable systems can be produce unbounded outputs leading to system failure. Here we have to see the diagrams of stable and unstable systems. The stability analysis is a crucial for ensuring reliable system performance. Conclusion. Conclusion for signals and systems. Signals and systems form the foundation of a modern engineering and technology. The proper classifications helps in selecting a suitable processing techniques. Understanding these concepts is essential for designing effective communication, control, and signal processing system. Thank you.